Here is a question of UPSC. In this question, it is asked, find the number of zeros at the end of the product this. 1 to the power 1 factorial, 2 power 2 factorial, 3 power 3 factorial, so on up to 10 to the power 10 factorial. In this product, at the end, how many zeros are there, we have to find out. For this, in any number, suppose if you take 100, how many zeros are there? 2 zeros are there. Say there is 1 zero. So 10 is nothing but your product of 2 into 5. That means if you get one pair of 2 and 5, that means 1 zero will be there. Two pair of 2 and 5, 2 zeros will be there. So like this way, it means number of zeros will be calculated by counting the number of pairs of 2 and 5. Or in any number, if you take 9 into 8 into 7 into 6, in this product, there is no zero at the end because 2 is there but 5 is missing. So 0 comes as the product of 2 and 5. So this is the main concept behind it. For this, now let us focus to this product. Here we will find only those factors where we will get 2 and 5. 3 we don't require. 7 no need. 9 no need to take. So if we approach this, now 2 to the power 2 factorial, we need it. 2 to the power 2 factorial into 3 not required because it will not contribute to zeros at the end. Okay, 4 to the power 4 factorial. Next 5 is there, 5 to the power 5 factorial. 6 2 into 3, so 6 to the power 6 factorial. Then 7 to the power 7 factorial, meaningless in this question because it will contribute nothing for the zeros at the end. So we need next 8 to the power 8 factorial, this is not required, into 10 to the power 10 factorial. Now you see, this 10 to the power 10 factorial, if 10 square is there, there are 2 zeros. 10 cube is there, at the end 3 zeros. 10 to the power 5 is there, at the end 5 number of zeros. Here 10 to the power factorial 10 is present. That means itself it's giving factorial 10 number of zeros. So it is confirmed because of this we will get factorial 10 number of zeros. Next part. Now come here. 2 to the power 2 factorial. So 2 to the power 2 factorial, that is how many 2's we will get? Factorial 2 number of 2's is here. Now this 4 is nothing but 2 square, that is 2 into 4 factorial into, for some time we are not taking this 5. Now here you will get 2, that is 6 is the product of 2 into 3. For our purpose 3 is not required, only 2 required. That's why 2 to the power factorial 6, or you can say 6 factorial. Next 8 is here, into 8 means what? 2 cube. That's why it will be 2 to the power 3 into 8 factorial. I think it's clear now. That means at first we are interested to collect the 2's. How many 2's will be there? So in this product, from which factor or which number you will get to, all we have written. 2 and 5 from where we will get. Now you see here only the two cases I have written here. 2 to the power factorial 2, 2 to the power this much. This many 2's will be there. Next, this 5 to the power 5 factorial into 5 to the power 5 factorial. How many 5 you will get? 5 to the factorial 5 number of 5 is there. And you just remember number of 5 always is smaller than number of 2's. Here you can see it is 8 factorial, 4 factorial. So if I combine 2 and 5, so how many pairs will be there of 2 and 5? Pairs of 2 and 5 will be how many there? Definitely factorial 5, because more number of 2's are there in comparison to 5. So you can say, that means simply we can say, if there are 20 number of 5's, then there are 60 number of 2, like this. Then pairs will be how many? So how many 5's are there? That many pairs will be possible to make. Though factorial 5 number of 5 is there, that's why we can say pair of 2 into 5 will be 5 factorial. Now see, here 2 into 5 factorial, 5 factorial is there. That is 10. 10 to the power 5 factorial. That is, let me write in a proper way here. 2 into 5. 5 to the power 5 factorial, and easily we will get how many 2's? 2 to the power 5 factorial 2's. That is, here if it is 120 number of 5's, then there are more than 120 number of 2's. That is 2 into 5 whole to the power 5 factorial. These many pairs, and it is nothing but 10 to the power 5 factorial. Already in the main number 10 to the power 10 factorial is present. So now number of zeros will be 10 to the power 5 factorial into, that means from this number pair of 2 and 5 we have observed 5 factorial, and already 10 to the power 10 factorial itself is there. So it is 10 to the power 10 factorial. That is nothing but 10 to the power 5 factorial plus 10 factorial. Now you are confirmed that there will be how many zeros at the end? 5 factorial plus 10 factorial. This is your answer. At the end of this number, there will be 5 factorial plus 10 factorial number of zeros will be present.